Hai guys, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Apa kabarnya, sehat?
Alhamdulillah sehat.
Oke, baru 17, 18 mulai masuk. Oke. So let's start our lesson because we have a very limited time. We have only 20 minutes. So I'm going to start directly the lesson, and don't forget after you finish the lesson to fill out the attendance list that I share to your groups. So you will click that attendance list and you will find your name. If you don't do that, so you are marked as an absent. So please don't forget after each session, after you finish, to go out to the link and fill. Okay. Today we have only 20 minutes. I'm going to show you some of the things. First, I'm going to all of you, so nobody will speak. Okay, today I'm going to discuss about the topic that I gave you the homework assignment about exercises calculating the relative atomic mass and relative molecular mass. Last week we learned about this and I gave you the assignment, and I'm going to discuss, I'm going to explain how to answer the question that I gave to you. I gave 6 questions to you, okay? I'm going to share my screen. I'm going to show you. Sorry. So this is the exercises. So everybody please take a look at what we did already. Sorry for the internet. Okay. Now this is the exercises relative atomic mass and molecular mass. I'm going to start with number 1. Look at the question for number 1. Okay, I took some of the answer from your friend. Maybe you are laughing for the one who got this answer. Maybe you understand whose handwriting is this. Okay, I get some of your friend handwriting and the good explanation from your friend, so we can take advantage from your friend. The question was this: boron have 2 isotopes, boron 10 and boron 11. Boron 10 is 10 SMA and boron 11 is 11 SMA. Boron 10 20%, boron 11 8%. Sorry, I'm still hearing some noise, so I'm going to mute all of you. Okay, so how to answer this question? What is the average mass of boron? We know that the average mass, if we have percentage, so you will get the average of this. 10% of 10 boron 10 and 80% of boron 11. So 10% times 10 plus 10% times 11 divided by 10%. This 10% in the denominator, you know that this is 1. So 20% times 10, it is 2. 80% times 11, it is 8.8. When you sum up these two, you will get 10.8 AMU. This is the mass of boron atom, the average mass of boron atom. I think it's very simple mathematical calculation that you do to solve this problem. Okay, it's easy, yeah, for number 1. Let's continue with number 2. Okay, number 2, this is the question. Copper have 2 isotopes, copper 63, copper 65. If the relative atomic mass of copper is 63, 3.5, find the abundance of each of the isotope. So this is the reverse of the first question. If the first question you are given the abundance, you find the relative atomic mass. In this question, relative atomic mass is given, you are asked the abundance, how many percent for each, copper 63 and copper 65. I think it's the same calculation. What you will do is just you reverse the calculation. For this, let's make an assumption. So let's say that copper 63 as X percent, because we don't know the abundance copper 63. Let's say that copper 63 is X percent and copper 65, obviously if copper 63 X, so copper 65 will be 100 minus X. For copper 63, it is 63 AMU, copper 65, it is 65. So when you sum this one, you will get 63.5. So by a very simple mathematical calculation, you will get the X. So 63.5 is equal to 63 times X percent. 63 times X percent, so 63X percent plus 100 minus X times 65%. Sorry, 100 minus X percent times 65. So when you rearrange this one, you will get 60,500 minus 65X percent. And it is, you sum with 63X percent, you will get 63.5. When you do mathematical calculation for this, yes, this is normal mathematical equation, and you will get that X is 75. So when you put here, so copper 63 will be 75%, and copper 65 will be 100 minus 75, you got 25%. So it is very simple mathematical equation. Okay. For number 3, let's see number 3. What was the question for number 3? If the mass of one atom of carbon-12 is 1.99 times 10 to the power minus 26 kilogram, and the mass for one atom of X is 6.63 times 10 to the power minus 26 kilogram, find the relative atomic mass of X. We know the formula from last week that the relative atomic mass of an element is equal to the mass of one atom of that element over 1/12 times the mass of carbon-12. So according to the formula, you will get this relative atomic mass of X is equal to the mass of X over 1/12 times the mass of carbon-12. So the mass of X is given in the equation. It is 6.63 times 10 to the power minus 26 over 1/12 times the mass of carbon-12, also given in the equation 1.99 times 10 to the power minus 26. When you cancel this 10 to the power minus 26 and you calculate this one, you will get that the relative atomic mass of X is 39.97. Or you round up the number, it's become 40. Okay, let's continue with another exercises for the relative atomic mass and molecular, no relative molecular mass. Calculate the relative molecular mass of the given compound. It is very simple to find the relative molecular mass. If you know the relative atomic mass data, you can get it from the periodic table, then just you will sum up those data, but some of the things you have to mention. For example, P4 here, it's mean that 4 times the relative atomic mass of P. So 4 times the relative atomic mass of P. The relative atomic mass of P you can get from the periodic table. It is 31, so you will get the value of relative molecular mass of P4. For B now here, iron is 2, so 2 times relative atomic mass of iron. And sulfur here, sulfur actually it do not have any subscript here. But remember the one which is under parenthesis, you have to mention also the number outside the parenthesis. It's mean that here we have 3s and 4 times 3, which is 12 oxygen. So here, that's why it is 3 times relative atomic mass of S and 12 times the relative atomic of oxygen. So you will multiply the number outside the parenthesis. After you put the relative atomic mass of each of the element, you will get the relative molecular mass. The same thing with the C, 3 times Ca, 2 times P, 2 times 4, 8, 8 times oxygen. So you will get this one. Now for this is a little bit different for D. K is 1, okay, 1 time the relative atomic mass of K. Aluminum also 1. Sulfur it is 2. Oxygen it is 2 times 4, it is 8. 8 times relative atomic of oxygen. Now, if we have a dot here, it means it is hydrate, and we have the number in front of the hydrate. Hydrate is H2O, it is water. In front of the hydrate, normally sometimes we have a number like this, 12, for example. So 12, it also will be calculated in here. So 12 times 2, it is 24 times the relative atomic of H, and 12 times 1, which is 12 times the relative atomic mass of oxygen. So when you total this one, you will get this number. And for E, it is also the same, 4 times the relative atomic mass of potassium, 1 time relative atomic mass of iron, 6 times relative atomic mass of carbon, and 6 times relative atomic mass of nitrogen. After that, you will get the result. Okay, this is also simple. Let's continue with question number 2. If the relative molecular mass of LOH3 is equal to 70H, and relative atomic mass of hydrogen is given as 1, you can get also this number from the periodic table, and relative atomic mass of oxygen is 16, find the relative atomic mass of L. L is not unknown. It is unknown, yeah? This is an unknown substance. We don't have a substance with the symbol L. L is an unknown substance. So we're going to find L. What is L? So to find what is L, first you have to find the relative atomic mass of L. How to find the relative atomic mass of L? It is very easy. The total molecular mass is given, which is 78. So 78 will be equal to 1 time relative atomic mass of L plus 3 times relative atomic mass of oxygen, which is 16, and plus 3 times relative atomic mass of hydrogen, which is 1. So relative atomic mass L plus 3 times 16 plus 3 times 1. So you will do a mathematical calculation here. So this is RL plus 48 plus 3 equal to 78, the relative molecular mass of this compound. So from this, you will get that relative atomic mass of L is equal to 27. When you go to the periodic table, you will find that this 27 is aluminum. So this L is aluminum. Later on you can check that relative atomic mass of aluminum is 27. So it is very simple. Just you will find this relative atomic mass of L by doing this simple mathematical equation. And the last question, this is also a very simple question. A compound with the empirical formula. This is important. It is empirical formula. This is not molecular formula. When you go back to our previous chapter, we learned that empirical formula is the simplest formula, which is mean that it is not the molecular formula itself. It is the simplest form of the formula. So the simplest form of the formula is CH3. So it doesn't mean that this molecule or this compound, the formula is CH3. No, it can be C2H6, it can be C3H9, the molecular formula. It depends on what is the relative molecular mass of that one. So that's why it is given the relative molecular mass, which is 30. So you are going to find out what is the molecular formula for this. So it is very easy because we know the empirical formula is the simplest formula. So when you multiply that empirical formula with a number, then you will get that molecular formula. But we don't know what number that we're going to multiply. For this one, we multiple, let's say that multiple this empirical formula with the X. So with X, if I multiple the empirical formula with X, then I will get the formula CXH3X, okay? And when I calculate the molecular formula for CXH3X, what I will get? X time relative atomic mass of carbon plus 3x times the relative atomic mass of hydrogen. So when I put this number, relative atomic mass of carbon, which is 12, and relative atomic mass of hydrogen, which is 1, so I'll get 12 times x plus 3x times 1. So I will get 12x plus 3x, which is 15x. And this is equal to the total relative molecular mass, which is 30. So 30 is equal to 15x. From here, I'll get the x. X is equal to 2. So from here, I understand that if x is equal to 2, then the molecular formula for this one, which has the relative molecular mass 30, is equal to C2H6. C2H6. So if I'm changing this one, for example, it is 90. If it is 90, so it will be 90 here. 90 equal to 15x. What will be the x? Anyone can answer? Can open your mix. If it is 90 here?
6.
6.
Yes, if it is 90 here, then x will be 6. So what will be the formula?
C6 H
H12. C6H12.
So the formula will be
18
6.
18.
C6 H
18.
6 H18.
Yes, good. So this is what we do in our previous lesson. So example of question that can be come up in the exam is like this. Do you have any question, guys? Do you have any question? No question? Okay, if no question, it is clear, yeah? This is how we find the relative atomic mass and relative molecular mass. Tomorrow, we are going to do mole. Okay, we are going to learn the mole. What is mole? What is molar mass? And what is molar volume? And after that, I'm going to give you another exercise for that mole. Please, tonight, before you come to the class, you read about that one. You will read about the mole, molar mass, and molar volume. This is what we're going to see tomorrow. Okay? Yeah, let me see who is here in the classroom. Everyone is here, yeah? Thank you. Dipa, Pala, Farhan, Demas, Alif, Eza, Ryan, Nur Abdi, Lutfan, Fikri, Ilham, Rian no video, Ivan no video, Eric no video, Afif no video, Adi, and Agus and Ramos. Thank you.
Thank you, sir.
Okay, please stay tuned on the Google Classroom. Sometime I'm going to share you some of the things so you will look at what I'm sharing. Okay, see you tomorrow. Do you have any question? No? Thank you. See you tomorrow. Assalamualaikum warahmatullahi wabarakatuh. Please
Waalaikumsalam warahmatullahi wabarakatuh.
don't forget to fill the attendance list in the groups. Okay? See you. I end the meeting. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.